Welcome back, students. This is the Q&A session 6 from the chapter of motion in a straight line. And the question here is, the acceleration experienced by a moving boat after its engine is cut off is given by A is equal to minus K VQ, where K is a constant. If V naught is the magnitude of velocity at cutoff, then the magnitude of the velocity at any time t after the cutoff is given by, these are the four options which are given to us and we have to find the correct one. So here we have the acceleration experienced by a moving boat after its engine is cut off is given by A is equal to minus K VQ, or we can say that now acceleration is given by dv upon dt, that is the rate of change of velocity, that is equal to minus K VQ, where this V is the velocity at any moment of time. Now यहाँ पे ये दिया हुआ है, it is given that V naught is the magnitude of velocity at cutoff. V naught is the magnitude of velocity at cutoff, or we can say it is the cutoff velocity. Now, if if V naught is the cutoff velocity, then cutoff time will be given by t is equal to 0. If because V0 is the magnitude of the velocity when the engine is cut off, so at that moment of time we can consider the cutoff time as t is equal to 0. So now here what we will be doing is this dv upon dt is equal to minus K VQ. So I will be writing this expression as, it implies that dv is equal to minus K VQ dt, or it can also be written as dv upon v cube. I have taken this v cube on the left hand side of this equation, which is equal to minus K dt. Okay, so this is what I have got from this equation, that is A is equal to minus K V cube. Now integrating this equation under the conditions which are given in this question, we will get, now I am just writing it here, that integrating this equation on both sides, that is I am writing this equation as 1. This is the equation 1. So integrating equation 1 on both sides, we get dv upon v cube, and this will be integrated from v naught to v, and this will be integrated as minus K dt from, that is t is equal to 0 to t. Because we have taken this cutoff time as t is equal to 0, and at t is equal to 0 the cutoff velocity was v equal to 0. So we will be integrating this equation can be integrated as, that is on the left hand side I am getting the limits as from v naught to v, and on the right hand side it will be equal to, that is from t is equal to 0 to t. So now we have to simply integrate this equation, and we will be able to get the value of the, or you can say the magnitude of the velocity, that is v, in terms of v naught, k and t. So so from here, if I integrate it, we will be getting, or simply I can, if I will integrate it, then it will be, can be written as v minus 3 dv is equal to minus k. I am just taking this, k is a constant, so it can be taken out, and it will be from 0 to t dt. So it implies that when we will be integrating this on the left hand side of this equation, we will be getting at v minus 3 plus v minus 2 divided by minus 2, and this is from v naught, sorry, this will be from v naught to v. So this will be, it implies that the integration of this will be, we will get as v to the power minus 2 divided by minus 2 from v naught to v, which is equal to minus k t from 0 to t. So this is what I am getting right now after integrating both sides of this equation. So solving this, yeah, so this is equal to and at the same time we will be also getting one, that is when we are integrating it, we will be getting one constant of integration also, which is called as c. So now I will be putting the values here, and I will be getting this as minus 1 by 2 v square, and it will be from v naught to v. This is equal to minus k. That is equal to t minus 0 plus c. So solving this, we will be getting, it implies that minus 1 by 2 v square minus 1 by 2 v naught square, this is equal to minus k t plus c, where c is the constant of integration. Now at t is equal to 0, we have seen that at t is equal to 0, at t is equal to 0, v is equal to v0. So I will putting this, so I will putting the value of t is equal to 0. So what I will be getting, that v is equal to v0. So the constant of integration will be equal to, this is equal to 0, and v is equal to v0. So this will be equal to, c will be equal to, this is equal to, sorry, this was equal to minus 1 by 2 v square, this will be equal to plus हो जाएगा, ठीक है, minus and minus will be equal to plus हो जाएगा. So this is equal to minus 1 by 2 v square plus 1 by 2 v naught square, and this is equal to minus k t plus c. So at t is equal to 0, v is equal to 0. So if I put the value of t is equal to 0 here, and if I put the value of v is equal to v naught, then c will be equal to 0. So finally what I am getting the equation is that minus 1 by 2 v square plus 1 by 2 v naught whole square, this is equal to minus kt. Now solving this, we can we have to find basically the value of v. So what I will be doing is, it implies that I will be taking 1 by 2 v square on one side of the equation, and this will be taken on the other side, that is equal to minus kt. This will become to minus 1 by 2 v naught square. So it implies that minus 1 by 2 v square is equal to, I will be taking the LCM of this, so I will be getting as 2v square. It will be minus k t minus minus 2 v naught square kt minus 1. So this can be written as, I will be 1 by 2 v square is equal to 2 kt v naught square plus 1 divided by 2 v naught whole square. So 2 and 2 will get cancelled out here. Okay. So finally, here I am getting that v square is equal to v naught square divided by 2 kt v square plus 1. Or simply we can say that v will be equal to v naught divided by 1 plus 2 kt v square, v naught square. So the answer is, that is the magnitude of the velocity at any time t. At any time t after the engine is cut off will be equal to v naught divided by under root of 1 plus 2 kt v naught ka whole square. So here the answer is v naught divided by 1 plus 2 kt v naught whole square. So the correct option is D. So in this question, the most important thing is that, here we have taken the here the acceleration is given as a is equal to minus k v cube, and so I have written this acceleration as dv upon dt minus k v cube. And then at the time of integration, you have to take one important thing into consideration, that while integrating, that is when I got this equation in the form as v naught v cube divided by dv, which is equal to minus k from t is equal to 0 to t dt. So this is what I got this equation. But when you are integrating this equation, you will be also getting one constant of integration. So that has to be taken into account. And in order to get the value of that constant of integration, we have to put the value of t, that at t is equal to 0, v was equal to v0. This was a thing which we have already assumed, or we have we have taken that at when the engine was cut off, the velocity was equal to v naught. So at the time of when the engine was cut off, we have taken the cut off time as t is equal to 0. So putting these conditions while integrating this equation, we were able to find the value of the constant of integration. So after putting the value of the value of constant of integration, we were able to find the value, that is the magnitude of the velocity at any time t, which is equal to v naught divided by under root of 1 plus 2 kt v naught whole square. So the correct option here is D. And so this is a good question which I have taken from one of my reference books. So in the next session, that is in the session number 7, I will be coming up with some with another good question. So till then, have a nice day. Bye.